Alright, you've just met with your team. You've defined key objectives. Perhaps you've decided to reduce your fixed cost structure, and you have 30 different ideas on how this might be achieved, and you want to apply artificial intelligence or machine learning to get this done. What then is the next stage of the strategic planning process? I will call this the audit phase. This will be a very involving process where you're looking at both internal and external resources, planning for additional data collection, and applying a number of different machine learning tools to simply understand what kind of data we have. Do we need to change that data, and can we possibly exploit that data in order to reach our objectives? This process often involves the use of unsupervised machine learning tools, data reduction, and cluster analysis. In my generation, we used to call this data grubbing. The audit phase may be one of the more difficult aspects of machine learning. It is often slow because the data are not perfectly clean, or we simply don't have the right data. However, you will find that if done well, this may have the highest return on investments. This is especially true if your data are unique, proprietary, or somehow give you a competitive advantage. Why is this often considered the hardest part of machine learning and artificial intelligence? Well, let's just take a small case study. Suppose someone wanted to increase their sales, let's say by 20% by the third quarter, and we want to exploit these new fancy tools. What you're going to do is you're going to dig into your own databases and you're going to look for things like customer list and our marketing expenditures, maybe customer reviews or blogs that we have harvested from the internet. And we're going to look to see if there's a relationship between those data and sales levels. At one point, you might realize that that's not really the data I need. What I really want to know is the competitive positioning of my brands. You will then call the marketing department and they'll say, well, we don't really have data on that. So you might buy an industry report or call a consultant. Or maybe you'll just forget about doing any further work because you have to collect data from a number of different departments, all in different formats. None of the data are clean, and you just give up. That is rather typical. I've never really met anyone who enjoyed being a data auditor. Well, don't despair. If your objectives are very clear, usually the amount of data required for the most advanced modeling efforts is fairly narrow. In the good old days, managers used to do broad business audits using various frameworks like the SWOT analysis. In the world of data analytics, there is a process of collecting private and public data, very well understood techniques for cleaning and transforming that data, and making sure the samples we're using are indicative of what might be useful for the final outcome of a model. It turns out that the analysis of the data using unsupervised machine learning methods is actually extremely fast and not very costly. Okay, so this audit phase, or data grubbing phase, involves two components. One is called data processing. This is where you're collecting data, cleaning data, transforming data. The second part is analyzing the data. Now at this phase, I'd highly recommend that we focus on unsupervised machine learning techniques. These allow us to understand if the data are correlated to each other. What are the stories that data are telling me? What kind of narration can I create? This phase of the process is often very inexpensive and can even be run on most modern laptops. Now at this stage, you might be wondering, what is this unsupervised versus supervised stuff? As we're focusing on unsupervised, let's start there. Imagine you've got a massive database, hundreds and hundreds of variables. Question, do those variables relate to each other? Do I really need to think about all of them? Can I maybe pick just a few? That's the question that is often addressed in unsupervised machine learning. If you look at the equation, a plus bx1 plus cx2, there's no y. It's just a bunch of data, and I want to know something about what's behind that data. If I want to predict something or explain something, that means I have a y variable. Now I'm actually using supervised machine learning techniques. So what's the fundamental difference between the two? In one case, there's a y variable. I'm trying to explain something. In the others, I just want to know what the data are. That is unsupervised machine learning. It's very popular at the cleaning phase because I don't want to have some bias about what I think the data should be telling me. I just want to know what the data are. So what you'll be wondering is, where's the money in all of this? We'll get to that a little bit later. To illustrate unsupervised machine learning, we're going to start with data reduction algorithms. Let's begin by talking about how humans do it. Imagine human beings are trying to compare products. How do they actually do it? Well, in the good old days, people used to do what was called benchmarking studies. You would take a bunch of products, take them apart, and then measure exactly what was the difference between one product and another. This was a very useful and is still a very useful tool to compare competing products. Later, we came up with something called the relative value proposition. You would take the tangible aspects of a product and you would create a quality index, and then you would set another index on price, and you would simply plot where different brands were in that space. For example, those below the 45-degree angle line, those are products that are probably at a competitive disadvantage. The ones above the 45-degree angle line are the ones that have a competitive advantage. But if you look at the market shares of these companies, you'll notice that brand C is very unusual. It has 55% market share. That shouldn't be the case. Clearly, brand A or brand D should do better than brand C. But brand C is still performing well. Maybe quality and price are not the key variables upon which we should actually compare products. Maybe human intelligence doesn't operate this way. Whenever consumers are making a choice between competitive products, they don't use all of the technical features to make their choices. They might boil it down to one or two things. Toothpaste is extremely complex. However, we don't actually use everything about the chemistry of the toothpaste to make a choice. Imagine we have a focus group, and we bring people in together to talk about automobiles. We'll ask them, what makes one automobile different than another? And people will start listing things off at the top of their heads. Things like the weight, the color, the handling, the fuel efficiency. After about 5-10 minutes, you're going to see that they will list 20, maybe 30 different attributes of automobiles. Now, do people really use 30 different attributes? Suppose we ask them a question. How good is this car on roominess? 1 is bad, 5 is great. And for a particular car, they'll say 1, this car sucks. And then you ask them a second question. How good is this car on seating capacity? And they might also say, 1, it's bad. The answers to those questions are highly correlated with each other. In fact, that is what one finds in most datasets. Often the data are highly correlated to each other. Using data reduction, we look for those correlations. Maybe we can group certain questions together. Let's call that a factor. And we'll group other questions together. Let's call that another factor. Those are the bases of competition. On what basis are people choosing automobiles? Okay, so after we train the computer using some survey data to reflect the minds of consumers, what does the output typically look like? It's called a perceptual map. In this case, Americans perceive the automobile industry along 2 core dimensions. Now, I will admit, this is my generation. The 2 dimensions are luxuriousness and sportiness. On those 2 dimensions, we can plot every competitor in the market based on the average of consumers' perceptions. So if I'm going to train a robot to perceive the world the way humans do, often we'll use principal components analysis, PCA, factor analysis, or multidimensional scaling to train the robot. Why? Because humans use data reduction. Therefore, the machine should mimic human minds. In this case, it's called a positioning study. We notice that Ford, Chrysler, and GM are a competitive cluster. We can use cluster analysis to identify which brands are closer to each other than to any other brands. If Jaguar, for example, drops its price, Cadillac probably doesn't have to respond because the 2 products do not compete in the minds of customers. The 2 products are differentiated from each other. During the oil shocks of the 1970s and 80s, people left their competitive cluster and started buying Opel, Volkswagen, Toyota, Honda, Datsun, which is now called Nissan. At one point in history, there was a large gap in the middle of the map. This was eventually filled by Lexus, Infiniti, and Acura. Later, BMW and Mercedes-Benz filled that gap as well. Eventually, Ford acquired Jaguar to try to also occupy that space. A perceptual map is a strategic planning tool, but more importantly, we relied on unsupervised machine learning to give us a picture, a narration, a story. What do the data tell us? In this case, it gives us competitive clusters and competitive positioning of products. Often, data from unsupervised machine learning is used as inputs into supervised learning models. For example, if we want to forecast the profits of a company, it may be due to the competitive positioning it has on a perceptual map. Profit is the Y variable. The coordinates on the map are the X variables. The X variables were derived from unsupervised machine learning. The two methodologies used involved data reduction and cluster analysis. Both R and Python are excellent languages to approach unsupervised machine learning. And as I mentioned earlier, Excel spreadsheets often are a great way to brainstorm with the team live interactively, where you can also demonstrate or use data that your company has collected and visualize it as factors or clusters. One of the drawbacks of machine learning is that you have to have clean data. Garbage in, garbage out. So the process will always be the same. When you audit the data, you're going to be cleaning it, sorting it, transforming it, making sure everything's proper. Then you go to data reduction. See if the data are redundant with each other. And then finally, you'll do a cluster analysis that may give you insights into similarities or groups or segments. Remember, the data cleaning process is the slow part. Doing data reduction and clustering can take as little as 1 or 2 weeks once the data have been cleaned. Let me end with a little bit of advice. After you've done your objectives workshop and you're on the data audit phase, give yourself a week or two to quickly look for all of the internal data and all of the possible external data. Plan for questionnaires in case you might be missing some data. And when you get the data clean, remember, the machine learning tools are extremely fast and not very expensive to run. Therefore, don't really worry about which tool is better or worse compared to another tool. Just run them all and enjoy the visuals.